again here. Active scene. So start recording myself. Okay, so now I'm going to my Audacity. Audacity should be able to record this now. Let me just make a breakthrough now. I actually like that because more of you are conscious that's doing that, guys. I'm recording now. So let me try to now set up the system to get it properly done. Allow. Okay, so my thing is going now. So I'm gonna do my lecture now. So, basically, guys, this video is not done. So we have to do it properly. My 30 minutes time I started. Okay, so basically, guys, the GSM files, the manuscript files. You can use the .gs files for the GSI files for the interpretation, for the bridge to other words, based on MMUKO. M for mother, M for Mike, M for Mike, U for umbrella, K for kilo, O for Oscar. That is Muko dash O for operating, S for system, Muko systems. The spirits of good and evil that connects us all. But it's a quantum system for bridging, so you have to align with the polar color system. So basically, remember the half rule. So basically, if you want to is a direction. If you want to times by 2, you go up the ratio as a policy. The computer enforce that policy, like a Python decorator. So if you have half of something, that's 1. Half make 1. We have 2 of something, you want to reduce it. 2 of something, you want to reduce it, you go half of it. So basically, this is just a model of it, but it's for general clarity. So a half is a whole. A half is a based on a system of the conjugate systems of transformation and rotation. Yep. Translation. A half of x, a half of y, half of y has a 1, and half a half. Basically one half. It's half a half principle to one to whole principle. That's the idea. Between all the things you do, from rotation all the way from rotation to the system's coherence. So basically, yes. So this is my model of it. It works very well, but you have to understand the sparse matrix is intact. The sparse matrix is just the encoding of the sparse matrix for the quantum system. The Oracle 2 public key, 1 private key. So you can have like say I'm a radio channel right now, and I'm in a quantum radio channel, and I want to call in with my phone call repository. F for phonetic, H for ham, O for umbrella, N for November, E for echo, C for Charlie, A for Alpha Lima, Alpha Lima. So that phone call library can be polyglot too, if I want to call people across dimensions. I really want to do that though, but I don't want to via the Rift bridge, because I want to try to speak myself today. I know I can fail, but it's just innovation. How it works. So I'm trying to call like a bubble instead of like a Cartesian coding system. I use the polar variant. Because this is a bubble world we're living. Basically everything is a bubble. The Earth is a round. The sun is round. Our universe is all round. So we live in a bubble universe. So if everything's basically our systems is bubble. Bubbles up. We bubble up. Basically our universe, our bubble universe is bubble theory. Consciousness is made of bubbles. We're all bubbles, and our own reality or not will pop. Etc. 2-1. 2-1. So have I done this already? Yes. So that's the half rule and the scale and the 1 rule. Half to 1, 1 to 2. So 1. So basically, for that we have to ensure that the translation of the 4 key rotations, translation, rotation, rotation, scaling. Scaling or shrinking, enlargement, and polarized correctly. So when you translate something and then you rotate it and then you skew it, but then you can trace the dot with an OBINexus, the rotation system DAG. The DAG should resolve in a consist way, tripartite consist way, because the tripartite consist way is very easy to use and ensure that system works coherently. For security measures, if you're able to pop your bubble intentionally, hack your computer and steal your data, you can do that quite easily. Because they work on the inverse alignment of you, so everything they do, they can guess the inverse of your data. Just basically, you can take the stream of your input and flip it to get access to your system, which is a bad thing, because if my computer blows up right now, I swear to God, I'll be screaming to head. You know, I want to do this for a long time. So I've tried to get two things. I have like a private key, two public keys. Two public keys. One for like connected to them, and another public key gets hidden. So that basically the jump of the bubble keys are there. So the also very basically goes a circle bubble key, and that's my universe, my bubble universe. And my other book, the X universe. So basically, I shut my eyes, I X my other public key, and then still links to that private key. But they're homogeneous keys. They work together. And can give me the same data. But you know, I have to switch, context switch between the two keys using my if then else policy. So if I'm using key A or key 1 and key A and key B, I'm using key B. I'm not using key B. So basically, when I use key A, I stick with key A until the session closes. So basically, if they say yes, I set up key A. But you do basically you have to go yes, yes, yes. If they say yes to our channel, I set up my key A. My key A will start talking, and they can relay whatever they want to say to me using key A. That's the public key. The consistency keys they're called. So when they have the consistency keys, I don't even tell them about key B. Where it is on my computer, but you know, there's a big problem with all of this, really, because if the public keys are in my system, they can find it anyway. Just try to get basically can try to find my root repository and try to just cd get whatever the null is, the nil is state, and just get it. Which I'm really scared. I'm not scared of it. I'm just like really wondering about my computer because it's the only one I have. So to do this properly, I get the circle key. I keep it in the own eye, so they can get that key. If they try to bubble up, the key will prevent them. Like, you know, I can give them the roots, but you know they can not know what that is. Because you know, that key will lock them down. But it's like a hard lock. It's like a dimensional lock. Because you know it doesn't lock to our dimension. It locks to other dimensions. Like a lock file. Like a Python lock file, or you lock the YAML, you know, lock files just lock our artifacts, lock system down, without any installation for temporary use of like a someone's version SSU. So the problem I'm really experiencing with this for security languages is like if I have one key and I have the other key, I have to hide it safely. By doing put in a coding layer, I don't this. So what I have to do is create a session in the directory I am for the terminal. W for Wink, S for Sarah, Y for Yankee, S for Sarah. That's the repository there. So if you go to the repository W S Y S, you can get the keys, get one key, to keep closed at all times until you continue the session. So they rotate. So when I use one key, I close one key. I close one key. Based on polarity. So if I'm using this key, I'm looking at this key. If I look at this key, I'm using this key. That key is loaded up. If I don't want to, if my session closed, I switch to the other key, and that other key is loaded up. It's dynamic loaded for public keys. But you know, I can only look at one key at a time. Because if I ever look at two, they have all my information. I can do anything more. So that's the first thing I'm gonna do. So I have two public keys and one private key. So the private key is just for metadata for me, my computer. If I want to isolate the system. Now the private key does the same thing. Can do the same thing, but just one key. One key. So the 2-1 or 1-2 mapping. So basically, I can have two private keys and one public key, depending on the networking topology set. But I'm trying to prioritize random choice prioritize something called polarity. So if I look at if I'm using the B key and the B key something happens to the B key, my system runs out and the B key shuts down. I can crash dump the B key and not get this without releasing information. Because the B key is started session already in the consensus framework. Using my IT, my private key, which I'm using. Which I'm trying to do. So if my computer breaks right now, I expect it to break. But you know, I'm doing it for science. I love science. Okay. So basically, dimensional reduction. So I'm observing the state of the world right now. I'm trying to do it properly. So that's also basically you can get 2-1 mapping on 1-2. We can resolve with a DAG. So if I ever try to do it properly, I can be polarized anyway. So I can get two pairs of two keys. So like 4 pairs. Basically, I have one facing the conjugate of plus negative. So the further out people that are more further out on the dimension domain. But that's mapped to the center key. Basically, you get 4 keys. 4 private keys for each dimension, a total of 16 keys, because you get basically a minimum of 16 public keys and 4 private keys in this system, because you know you don't know we're going to be polarized to. under something to do. If you know you're gonna progress, there's no point of you don't know the address you're gonna go to. So it's like it's like so you have to get security in mind. The oral seal algorithm, so you have to get 2 public keys, and for every 2 public keys, you have 1 private key. For any axis, minus minus, minus plus, plus, minus, and plus, plus. Okay, so based on where you are, your frame of reference in the bubble field, because you are working in the bubble. So how this works again is based on latitude, longitude. So I'm just talking to myself right now. So I have to literally just get punching statically or dynamic IP address based on the topology model. So I can literally what's this? Oh, 10. Okay, I can literally create try to create a 3D system where basically I'm in a 3D world right now, but I can polarize myself up dimension, look up, basically by polarizing myself, I try to access more dimensions than I actually am. So I look at 1, 2, 3, but I can't look up. I can't look up without scaling the magnitude of information. So for example, if I say I'm learning my half basically this information is there in the center. So basically we're in this universe. We can measure all of our bubble universe, but there's another universe here that's the center that has more information, but we can't lens it. We can't see all of it because it's too much, and we just get a glimpse of it. So we can try to look at the bubble universe for this model. So we can work it other way. Instead of looking at 2D video, we can use the 4D tensor system. So we can create a 4D tensor, a 5D or 6D. It doesn't really matter. But I'm gonna start with the 4D one. So the goal is this: you lens the 4D one or the 2D one. The 4D. So basically, get 4 times 4. The 4D times 4D. 4 times 4 plus, what do I do? So you get, let me try to work it out. So you get 4 times 4 times 4 times 4. So you get 4 plus 4 plus 4 plus 4. Oh, that's 16. Times